Okay, so it's now time to do Appendix 9.1, how to measure geological structures. So it's not enough just to be able to recognize a fault or recognize a fold or a dome, but you have to be able to write it down on a piece of paper and turn it into a geological map. So let's say that you've got a fold that is like this. Okay, you could measure the angle that this fold makes going in this direction, and that doesn't necessarily have to be the same as the angle it has going in this direction. So like for example, if I bend, can you see how I'm bending it? So this one on this side is bending down more than this one on this side. So we have to be able to write that down on a piece of paper. Now it gets even worse because a fold could also be doing this. It could be dipping into the ground. It could be plunging. So this fold would be plunging into the ground, and then not only do we need to measure it this way and this way, but we'd also need to measure the angle it makes going in that direction. So folds can be very difficult in order to be able to describe them. Same thing with a fault. So if you've got a fault, you could have a fault like this, and then you could have a fault like this. So you need to be able to measure the angle that the fault makes. So that's going to be called the dip. And then you also need to be able to measure the direction that the fault is going in. So that's going to be the strike. So the strike goes this way, and then the dip goes this way. And you need to be able to measure them both. The same thing for either your anticline or your syncline, because it could be oriented like this, or maybe it's oriented like that, or maybe it's oriented like this. So you have to be able to tell in what direction is it being folded. So the way that we're going to do this is going to be with a Brunton compass. And a Brunton compass is your standard compass. It's got the needle on it, and it's going to tell you which way is north and which way is east and west. And so you could, if the fault is going in this direction, you could say it's making a 45-degree angle with respect to north. But a Brunton also has another needle that is going to tell you the dip that it's going to make. So if you take the Brunton and you put it on its side and you put it onto the fault, you can measure the angle that it's making like this. So there's a little video that I'd like for you to watch. And so this video here will show you how to use a Brunton compass in order to measure strikes and dips and the plunges of folds. And then armed with that information, then you can put it onto a geological map and then describe to somebody else what the geology of a particular area is. All right, so it is now time to take the lesson quiz, which we will do in the next segment.